In part 8 we're going to look at rates of change and gradients. The first part is introducing rates of change. We're going to introduce the notation dy dx as the rate of change of y with respect to x. This is like the gradient, so dy dx is the gradient of the straight line. A curve by definition doesn't have a single gradient. We're thinking of the gradient at a point, the gradient of the tangent at a point on a curve. The process of finding dy dx is called differentiation, and the term itself, dy dx, is the derivative of y. The process of actually finding dy dx is given here. If y equals x to the n, then dy dx is n x to the power n minus 1. So we multiply by the power and then we reduce the power by 1. Here's an example. In this example we're given an expression for y, but this is given to us in brackets. We can't differentiate these. So the first thing we need to do is multiply them out. Now we can differentiate each term as we go along. So the first is 3x squared. The second, although there's a 5 in front of it, we can think about differentiating x squared, which differentiates to 2x, so we can think of it as 5 lots of 2x. 3x differentiates to 3. Any number differentiates to 0, which makes sense because numbers don't change and we're looking at dy dx as a rate of change. So if we tidy our expression up, we have dy dx. We needed to try and find this particular gradient at the point P. Point P is where x is 2, so we just need to put 2 into this expression. So we get the value 29. So the gradient at P is 29. Here is a typical exam question for you to try. Press pause, and once you've finished doing it, press play again to see the answers. Okay, to differentiate this, x cubed differentiates to 3x squared. We've got 5 lots of that. And x squared differentiates to 2x. So if we tidy this up, we have dy dx equals 15x squared plus 2x. We'll leave you with the key points from this section.